Assalamualaikum warahmatullahi wabarakatuh. My name is Arifah Ulia binti Sabri. My metric number AD220173. I'm going to present the introduction. For the introduction, first, in this project, we show how kinematic and kinetic of rigid bodies of complex engineering problem in real applications. And second, have two foundational concepts in the study of motion are kinematics and kinetics of rigid body. In that topic, we will characterizing the locations, angular velocity, and angular accelerations of objects and total moment of specific point provided by kinematics. Third, kinetics, on the other hand, delves deeply into the world of force and torques, revealing the complex interactions between these elements that propel motions. And last, rigid bodies are the objects whose shape doesn't easily change. For project overview, on this exploration of kinematics and kinetics in rigid bodies, our aim is to understand the topic more by choose dynamic analysis of revolving bus strip at an amusement park. By understanding the dynamics kinetics of rigid bodies, we enhance our theoretical knowledge in this project. Next, for the objective for this mini project are first, to understand the concept of kinematics and kinetic of rigid bodies. Second, to explore kinetic of rigid bodies in curvilinear translations. And third, to apply concept kinetic of rigid bodies on real-life engineering complex problem. And fourth, to identify and draw free body diagram based on information given by questions.
Okay. This case study involved the analysis of force and motion experienced by passengers on the Ashburn Park ride. The ride vehicle travels along a circular path, while rotating around a vertical axis and cause passengers to have a curvilinear translation. Ashburn Park rides are intricate dynamic systems requiring meticulous design and analysis to guarantee safety and passenger enjoyment. The force and motion experienced by passengers can fluctuate based on the ride geometry, speed, and rotation motion. Then the objective of dynamic response analysis. The dynamic response analysis for this amusement park ride has several primary. Okay, the first one is to calculate the acceleration and force experienced by passengers at different points along the ride path. And the second one is to evaluate the structural stress and strain on the right vehicle component. And the number three is identify any potential safety hazard associated with the right dynamic. And the last one is to assess the right performance under various operating conditions.
This study analyzes the dynamic behavior of a rotating amusement park bus. The ride is connected by two axles powered by a motor. We assume the bus is a rigid body, neglecting air resistance and developing equations for key parameters. We also have analyzed the factors affecting the ride and compared results within the safety regulations of the ride. That's all from me, which I will now pass the presentation to my groupmate Ijun Feng to explain more about the calculations of the ride which we have studied. Thank you.
Moving on to the calculation part, the question is to raise the 200 kg uniform bar AB in the vertical plane. The constant copper moment is equal to 3 kN is applied to the ring at point C. The mass of the ring is negligible. Starting from rest at 0 degree, determine the force support by the pin at point A, angular velocity, angular acceleration, and displacement traveled as the bar reaches the position 13 degree, 16 degree, and 19 degree. Following the question, the moment only occurs at point C, while no moment at point D. So this is our free body diagram of pin SC, and there is reaction force at tangent axis and normal axis. The reaction force at normal axis is parallel from the point, so that one will not be counted as moment. Here you can see that we got two formula at here. The first one is about the sum of moment at point C is equal to 0 when at the anti-clockwise rotation. Well, the second equation is about the center of mass of 200 kg of bar. Moving on to the free body diagram of bar AB, you can see there is 3 points, which is point A, point B, and point G. These 3 points, they got a reaction force acting on it, which is at the tangential and normal axis, but except for point B. Point B only got point at normal axis because point B, there is no moment acting on it. So the tangential force which is will be parallel to each axis will not possible occur at here lah. Here is the sum of moment at the center of mass G is equal to 0 at the anti-clockwise rotation. Ongoing this equation, we will get the equation 1. Then using the sum of force equal to mass times acceleration at the tangential axis, and then we will got equation 2. Now moving on, we will apply in the sum of force equal to mass times acceleration at the normal axis, and then we will got equation 4. So at initial we already got the equation 1. So now we are ongoing the substitution between both equations, and then we will get the reaction force at point A at the normal and tangential axis lah. So that one is normal mathematical calculation because that's too long, so I will not share it here. We know the velocity is equal to the rate of change of displacement with time, while the acceleration is equal to the rate of change of velocity with time. So we can substitution both velocity and acceleration formula, and then we'll got an equation is v times ds equal to a times ds. Since we know that angular displacement is equal to the radius times theta. So we can apply in this formula, substitution into it, and then we doing integrating both sides. Then we will got the velocity equation lah. So here is the velocity equation that we found before, and then here we got another angular velocity formula, which is angular velocity equal to velocity divided by radius. So we using both equation, and then we substitution our angle, the 13, 16, and 19 degree into it, and then we will got our velocity and angular velocity result. We already got the reaction force at point A at the tangential and normal axis. Now we apply in Pythagorean theorem. We can calculate the reaction force at point A with specific direction. So now we can substitution the 13, 16, and 19 degree, and then we will get what we want, the reaction force at point A. Now here is the acceleration and angular acceleration formula. As usual, we can substitution the 13, 16, and 19 degree, and we will got the acceleration and angular acceleration for both degree. Using the formula angular displacement equal to radius times the theta, we will got our final angular displacement for each degree, 13, 16, and 90 degree. Here is our analysis. We can see that when the position angle is increasing, the force acting at thing A increasing, but except for 90 degree, it will decreasing. For the velocity, acceleration, angular velocity, and angular acceleration will increase when the position angle increase, and same goes to the displacement also. When the position angle increase, displacement also increase. Now moving to the evolution part, our prediction was correct. The force acting at thin air is increasing when the angle rotation is increasing. When the bar is spinning at higher level, the bar need more force to pushing it outward. The angular velocity and angular acceleration will become higher.
Alright, as for the discussion, these case study reports explore the dynamic motion of the amusement rides, which focusing on the principle of translation and moment. Translation motion can be seen when a ride moves without rotation, which is controlled by a mechanism ensuring smooth movement. Uh, for examples like pirate ship or the park bus ride, which we know that where all parts are move along at the same curved path. The studies apply Newton's second law to amusement ride, which explaining that the force exerted when the ride starts in counterbalance by the right weight, resulting in stationary or slowly moving ride. This force is split into normal and tangent component. The moment or torque comes into play when the ride rotates about a fixed axis. The moment is the product of the applied force and the distance from the pivot point. The center mass of gravity, or the center of mass, where all the right mass is considered to be concentrated, play a crucial role in its motion. Okay, to conclude, the dynamic motion of amusement ride is an interesting application of basic engineering principle. By understanding this principle, it can help to improve the design and safety features of amusement park or rides in the future.
The dynamic motion of amusement rides serve as a captivating application of fundamental engineering principles, particularly in the realms of translation and moment. The dynamic motion of amusement rides serve as both a source of entertainment and a fascinating case study for the practical application of fundamental engineering knowledge. So that's all from us. Thank you.